So a quick question to the audience. How many of you have heard of Bitcoin? Blockchain? How many of you are building something with blockchain? Oh, see, it's a lot less. How many are you going to retire on your Bitcoin investments? None? Okay, fabulous. So here actually, in terms of myth-busting, is one of the first master's projects we actually got the centre, one of the students to do at the centre. So the centre was founded in about 2014, and we decided, we thought we were going to be a random bunch of academics sitting around discussing something cool called distributed systems and distributed ledgers and blockchain. And by the end of 2015, we were basically inundated with requests. It was actually just way too much. This, however, is one of the first visualizations that was ever done of what a transaction on the Bitcoin network looks like, and one of our master's students did that. And one of the key things to understand, obviously, the thing I really like about blockchain is the transparency. So you couldn't do this sort of analysis of any other transactions in the financial system because they're behind closed doors. So without having a wallet, we were able to just take every single transaction that had been done on the network and visualize what was happening. And actually what you see here, this big snake that we have, is actually the first attempted 51% attack on the Bitcoin network. So we caught it at a really exciting time. And from then on, I was hooked at least. But so let's have a think. What is a blockchain? So many of you here already know what this is. From a very simplistic perspective, we can think about a blockchain as something that allows untrusting parties to co-create a permanent transaction record without relying on a central authority. So obviously, in the Bitcoin's case, we can remove the intermediary of the central bank. The idea is that we no longer need a bank to do our transactions, and we can do it ourselves peer-to-peer. Another thing to note is blockchain distributed ledger. First myth, people often use these interchangeably. They're not, at least for me. A blockchain is a subset of a distributed ledger technology base. So why care about blockchain? So for my sins, I'm both an economist and a computer scientist. So I've studied both. Which means I'm equally bad at both? No, I'm joking. No, one of the reasons I really like blockchain, obviously, is it brings those two things together. You can't understand the technology without understanding the economics, and you can't understand the economics without really understanding the technology. So it's a really exciting time to be doing research in this space. But basically, blockchain really is about a lot more than just money or cryptocurrencies. It's a fundamental transformation in the way that we do business, or it could represent that in many industries. It gives us the opportunity to dramatically reduce the cost of operations, where we have traditionally got paper-based systems. We can create new revenue streams. And the other thing that it does is it can create data integrity. So many people say that blockchain is inherently secure. That, to me, is just completely wrong. It's actually a bit of a misnomer or a lie. It can provide data integrity. It is not more secure than any other solution out there. So that's the second myth I'd like to bust. So if you make a blockchain solution, you need to implement all of the traditional security mechanisms that you would in any other system. So, as I was saying, blockchain is really much bigger than just cryptocurrencies. We have, in the centre, done about 35 proofs of concept in a very broad range of industries. It's been extremely exciting, a lot of fun, very dramatic, very fast-paced, a little bit more than we as academics were expecting, to be honest. It's been great fun. We've had a lot of students actually spin out companies from their research, so it's been great. But we have looked here, so if you think about blockchain as a way to manage transactions, then we think about the different types of records that we can disrupt using this transaction base. So the records are currency, assets, contracts, data, and then peer-to-peer. And there are just a bunch of different types of use case applications that you will see on top. So some examples. Cross-border payments, you can do a lot in supply chain, logistics, smart contracts, for the legal industry are a really interesting space as well. The one thing that I think is really very, very important to remember or realize is that in order to do blockchain, you don't necessarily just want to be a disruptive startup. The best applications and the most successful applications of blockchain that I have seen have come from people who have significant industry experience and know how to apply this technology into a particular industry. So the example would be R3, which is a consortium of banks who have hijacked, shall we say, the approach of blockchain and put it into their way of doing business. Another one, which we'll go into, is Everledger. So as I said, distributed ledgers, there's for us 3 different types. The very traditional one on the far right, permissionless public shared systems, commonly known as Ethereum and Bitcoin, really. Everyone can read the transaction, everyone can write the transaction, and anyone can become a member of the network. So anyone has access to these networks. As a result of that very transparent system and great openness of the system, we also have to put an incredible amount of mathematical stability underneath to create the robustness in the network to make sure that fake transactions can't be put in. As a result, it also has quite a significant transaction delay. It's very, very slow for good reason. On the other side, we have permissioned private shared systems. An example is the Hyperledger consortium from the Linux Foundation, and they are permissioned private and shared systems. The idea being that you have to have permission to join the network, you have to have permission to write to the network, and also to read from the network. In the middle, we have what I refer to as hybrid systems, and those are systems where quite often the regulator might want to have overview of what's happening in the network. An example of that is a piece of work we did for the insurance industry, where the regulator was saying, well, it's okay for you to share information on this blockchain, but we need oversight in order to make sure there's no price collusion and there's no sort of antitrust issues. So those hybrid systems are where only a certain number of people are allowed to write to the network, but the regulator or another body might be able to come in and view what is happening on the network. So some examples. Here's an example of supply chains. So anyone in the UK must remember the horse meat scandal. It was the big thing we were worried about before Brexit. We had a bit of a problem with our food supply chain and the provenance of where things were coming from. There's also the big issue of counterfeit goods. So the Chinese government have actually been looking at using blockchain to try and reduce the number of counterfeit goods in their country. And also really high-end products like expensive wines needs provenance. And apparently there's a huge amount of fraud in the wine industry. So one of our groups of students put together something called Plinius, which was the provenance of food in supply chains. I won't go into great detail here, but they used the Bitcoin network to record every single transaction across the network as grapes became must, became a bottle of wine, became a crate of wine, and actually became a product for sale in the store. And the idea was the customer would be able to go in, scan the tag, and actually, this is a ham sandwich for some reason. Okay. So if you scanned your ham sandwich, you would be able to be told, yes, here's where the bread has come from. It's been baked in Waitrose, and here the ham has come from a particular farm. And then we would be able to drill down and say, well, the wheat has been grown in a particular place by this farmer, and maybe you have a story about the farmer at the end. So what is the problem with this particular installation? It sounds great. It's one of the beautiful examples that everyone always uses for blockchain. The biggest issue with this is how many transactions are you going to record? You're going to need a wallet at every single point of transaction along the supply chain. That's an incredible number of Bitcoin wallets if you do it this way, right? So it's not particularly efficient, shall we say. It's a great proof of concept, but it's not a very efficient way to do it. And the second thing is cost. So if you're going to do this for a ham sandwich, it's incredibly expensive. and it's prohibitively expensive to do it this particular way, unless you get forced to by Walmart. And then here we have the regulatory perspective, where let's say there's an E. coli outbreak on tomatoes, you can track and trace very quickly and shut down that part of the supply chain until it's fixed. As an example, here's a more sensible way to do supply chain tracking, which is Everledger, as I mentioned, a really interesting company tracking and tracing the provenance of diamonds, and proved a dramatic reduction in fraud. It also has a lot of other supply chain applications. One of the key things to think about when you're using it for supply chains, however, is that just putting something onto the blockchain doesn't mean the physical object is what it says it is. So there's an issue here around ensuring what is on the blockchain is really truly representative of the physical product. So Everledger came up with some very clever solutions to that, whereby they create a unique fingerprint for the physical diamond, and they register that on the blockchain. So it's not just putting the serial number of the diamond into the blockchain. It's a very important point when you're using physical goods on a blockchain. Simple one that I will talk about a little bit more about identity. This was an example from GradBase. We have a lot of issues with students lying about their degrees. They're not lying that they got a degree from a college, they are lying that they got a first instead of a 2-1. So they lie slightly in their job applications. Another problem is that employers have to pay 80 quid every time they get this check. And more importantly, sometimes universities are so overloaded, it's taken 3 to 4 weeks to get the reference back. And so students will miss out on a job because they haven't got their reference in time from university. So the idea is put it onto the blockchain. This is a QR code that actually works, and you verify it. And you get, yes, this person got a Master of Engineering in Computing in first-class honours. The idea being that it's verified by Imperial College in this particular case. The final one is an integrity solution that we did looking at how you would provide protection to energy networks to ensure that, the systems themselves haven't been hacked. And we did that with a company called GuardTime. And we just basically took a hash of the firmware, put that onto the blockchain. If the firmware hash changes, we know that something has happened on that system. Again, it doesn't solve the security problem. It gives you an early warning system that you need to go out and check something is on or do your final checks. Finally, if you are really interested in when and where to use blockchain, we did a paper with the World Economic Forum where we developed a C-suite framework, basically, that helps you decide when to use blockchain and when not to use it. So my final conclusion is basically, yes, this is a very useful technology. It's great fun. It's really fun to use and work with, but it's not useful everywhere. And sometimes actually implementing a blockchain costs you significantly more money than just using a database. So there can be false economies with this technology. And this is the very clear 11 steps that you would go through to check whether you would use a permissionless blockchain, so if you're going to use Bitcoin or Ethereum, or whether you would just use a database, whether there aren't solutions available for this yet, or where you would be able to use a private permissioned blockchain. That's publicly available. You just Google it and you'll get the WEF paper. And we have one coming up which is looking at crypto assets as well, which digs a lot deeper into what crypto assets look like and mean for the world's economy. And that's it. Thank you.
Thank you so much, Cathy. That was great. So we've got time for a couple questions. Anybody? Yes?
Hello. Hi. So in the Everledger example, at what stage in the supply chain is the diamonds being registered with its qualities? Because as I understand it, the diamond supply chain is very complex. So you have, it's rough, and then it's traded in batches and retraded, and then it's polished, and then that's traded in batches, so just very complicated and protracted. So is that at the very last stage, high-value diamonds are measured and registered so you can prevent fraud, or is that a proper mine-to-market solution for transparency?
Okay, so I haven't really looked tremendously deeply into their technology since last year, but from my understanding, it's mine-to-market. So, and it's actually quite in-depth. They've done quite a lot of understanding of how it transforms. And so, it's a good example of Leanne, who is the CEO. She knew the industry extremely well, and that's why they've been successful using blockchain there, because obviously it is extremely complex. And, as consumers, a lot of these supply chains that we work with look actually pretty simple. And so, hey, we can disrupt that with a blockchain. It's a lot harder than that, actually. So, yeah.
That gentleman there? Just behind, yeah.
Earlier you said that it's not necessarily more secure, but I thought that the whole, one of the big points of having blockchain is that it's decentralized, and therefore, if somebody wanted to hack, instead of hacking a centralized entity, the individual or the group of individuals will have to hack at the same time a decentralized system, which in terms of computer power, time, and so on and so forth, is just much more expensive than just trying to hack a single point of entry. So I thought that one of the things of blockchain is that it is actually more secure because of decentralization.
So, that's one of the myths. So let me put it this way. When you're building a blockchain solution, saying blockchain is more secure doesn't actually give you more security. So my point is, yes, what you have is data integrity, but it doesn't necessarily mean it's more secure. It's giving you a higher level of data integrity. It's harder to hack those solutions. What you would need to do, for example, if you're building a blockchain solution, is to ensure that you're still running the same security processes that you would on any other system. And not to do that is crazy. Is one of the, a lot of people have said blockchain is more secure. Well, firstly, more secure than what? They always just say it's more secure.
Decentralized versus centralized.
Yeah, but decentralized doesn't give you security. And that's why I think it's a myth. Decentralization doesn't necessarily give you security. We've had decentralized databases for over 30 years. The consensus protocols that are actually used within blockchain are pretty much a more advanced version of the stuff we already have had for 30 years. The unique thing about blockchain, in particular the Bitcoin blockchain, is the way that it was put together and combined. So I'll finish that off with saying one thing. Yes, no one has ever hacked a blockchain, but every single thing in the ecosystem around a blockchain has been hacked. And that's why it's not necessarily more secure. Sorry, I'm being quite pedantic about that, I guess.
Thank you very much, Cathy. That's
Thank
great.
you.
Thank you.